Hi there, I'm Eki and I work in a game company and have done games in Godot for a few years now. In this course you will learn how to create a first-person survival game with item gathering, crafting, hunting, cooking, and building. You will learn how to create a good systems architecture, project file hierarchy, and how to create high-quality, flexible, and scalable game systems with clean code. This course includes the following subjects: first-person controller, raycasts, animation player, audio player, particles, tweens, state machine AI, global event system for communication, inventory system, item equipping system, resource gathering, crafting system, building system, health and energy system, combat, day and night cycle, using plugins in Godot, multithreading, viewports, utilizing noise in a shader, lighting and a camera, creating custom resources, saving and loading resources on disk, and how to hook all those things up in a high fidelity way. If you are a game developer wondering how to create bigger games with robust systems, this is for you. On the other hand, if you are a complete beginner but a fast and motivated learner, you will have no trouble following along this course. Come with me and I'll show you how deep the rabbit hole goes. Alright, let's get started by downloading Godot. Head out to godotengine.org and go to the download section. In this course I will be using Godot 4.2.1, so download that one for your platform. If you can't see that version in this page, head out to the download archive and download it from there. It's best we all use same version of Godot. Once you have downloaded it, open it up and you will see this view. Let's create a new project with this new button. I'll call it survival game. And I'll save it in my documents. I'll create a folder there, survival game. For rendering, let's choose forward plus. And then just create and edit. Alright, and here we are. I'll just make a little bit more space here on the sides. What I usually do, you don't have to do it, but I like to move this scene and import tabs on the right hand side. So here when scene is selected, click on here, here, and same with the import, 3 dots, and this button. And the node, I'll move it down, so node and 3 dots, down here, same for the inspector, 3 dots and down here. And I'll drag this here. Alright. I'll switch those places too. So I like to have the Godot layout like this, but you don't have to do it. Okay, now you can download the assets zip file from the resources folder in the course content tab on the right of your course. Once you have downloaded it and extracted it, just drag all those folders inside the assets folder into your project, like this. Okay, now we have everything here. Before we start developing, let's edit some project settings and editor settings. So here on upper left corner, click on project settings. Under display, click on window. And let's make the resolution full HD, and that'll be 1920 by 1080. Let's also edit these stretch modes. So stretch mode will be canvas items and aspect will be expand. For almost every 3D game you will want these two stretch settings here, canvas items and expand. These two stretch settings determine how the game window will behave when you resize it, or stretch it, or shrink it, and stuff like that. Alright, we can close the settings now. Then let's head to editor settings. So click on editor, editor settings, and search type hint. And here, completion, make sure that add type hints is enabled. Now when using auto-completion when scripting, it will add type hints to the variables and functions and stuff like that. So it's very useful. Okay, then the next thing we can do is here in the meshes, let's save all the individual meshes into the meshes folder so we can use them later as we want. So we can create a new scene. Let's create a new root node for the scene. It'll be just 3D. This is temporary, it doesn't really matter. Then drag meshes.glb under the node 3D. Right click on meshes. And down here, make local, so we can access the individual meshes. Okay, so we have them here. Now what we can do is we can just drag each of them under the meshes folder and let's save them here. Okay, let's do the same for all of them. And that was the last one. Okay, now we can click on this X here and don't save, because that scene just was temporary for this procedure. Alright. Then let's start creating our game. First, let's do the island. A prototype island. So let's create a new root node, press on other node, and it'll be normal node class. Let's rename it main game. And Ctrl S, let's save it, or Command S on Mac. I'll right click here, make a new folder. I'll call it game. And I'll save it under the game folder with the name maingame.tscn. Let's create a new node here with this plus icon. It'll be another node. And I'll rename it Stage Controller. Now I will call different views of the game stages. For example, an island is a stage, then a main menu will be a stage, and for example, the credits sequence will be a stage. So under Stage Controller, you can create a new node again, just a node, and I'll call it now Island. Alright. Now let's get the ground mesh for the island. We can get it here from meshes. And I just noticed I accidentally put the terrain in the root of the file system. I'll drag it under meshes. And then we can drag it from the meshes folder into the scene. I'll just drag it under island, like this. So there's two ways of instantiating these custom scenes from your file system. You can either way drag them from here, or you can press this link button from here and you can instantiate it from there, from a list. Let's try that one. I'll click on island and then the instantiate child scene button here. I'll add a couple trees here. So I'll search tree and I'll select that, and yes, here we have a tree. With Ctrl D you can duplicate it. I'll create a couple ones, like so, and I'll add a couple of mushroom scenes also, just to have some perspective of the sizes and distances. And I'll move the mushrooms in the island node, like this. I'll add a temporary water here, so under island, add a new node. It will be mesh instance 3D. I'll rename it water. And here Under the mesh slot, let's create a new one. It will be a new plane mesh. Click on it to open it, and the size, it'll be like, let's make it 2000 by 2000 for now. And I'll move it down, something like this looks nice. And let's create a material for it. So in the material slot, new standard material 3D, open it up. We want some transparency in it, so click on transparency. And instead of transparency being disabled, let's select alpha. And then from albedo, we will set the color for it. So let's make something nice and blue, like this, and some transparency also. I think that looks nice. Alright. That water will be just temporary, so don't worry about it too much. Then let's create a sun. So under island, let's add a new node, directional light, 3D. I'll rotate it a little bit. And here under shadow, let's enable shadows, like that. And light. The color, let's make it a little bit yellowish. So I will have it of value FEFFBA. A little bit yellowish. That looks nice. Let's also add a new world environment node here. So under island, create new node. World environment. Under environment, let's create a new one. Open it. Background, the mode, it won't be clear color, let's make it sky. And then here in sky, let's create a new sky. And sky material, it will be new procedural sky material. Alright, open that up again. Under sky, let's make some colors for the sky. So for the top color, I will choose 53 E0FF. And horizon color, I will have it as ABC 8D4. We can copy this value. And for the ground horizon color, I will paste that value. Alright, that's all we need for now. We can close the sky setting here. And then let's add some ambient light. The color will be same as the sky top color, so that was 53 E0FF. And let's reduce the sky contribution a little bit to something like 0.5. So half of the light and color we will get from the ambient light, and the other half we will get from the sky. Alright. And that's it for this episode. We have created a nice island here with placeholder assets. And in the next episode, we will be adding the player character and setting up the movement for it. By the way, if you have your own 3D assets and textures, you can use those, but I provided you with these free assets here, the meshes and the audio textures. But if you have your own assets, you can use them, that's completely fine. The audio is provided by Zapsplat, the meshes are done by me, and the wolf and the cow meshes and their animations are provided by Quaternion, and some of the textures are being provided by Kenny and rest by me. Alright, see you on the next episode. Alright, welcome back. Let's create now our player character so we can move around and look around and jump and sprint. First of all, let's go to the project settings to add some input actions for ourselves. So input map tab, add new action, let's have move left, move right, and by the way, press enter after writing the name, then move forward, move backward, then jump, sprint, and lastly interact. Like that. And then let's add the input keys for them. So here on the plus icon for the move left, then I'm gonna move left when I press A, so press A, and then OK. And let's do the same for the rest. Move right, that's gonna be D for me, forward W, and backward S. Then jump, it'll be space, sprint is shift, and interact, I'll have that on E. Like that, and then we can close this. Let's create a new scene from the plus icon here. This will be our player scene, it will be other node, and let's choose character body 3D. I'll rename it player, and I'll already save it. I'll have it in a folder called actors, and I'll make another folder here called player. And I'll save it here, player.tscn. So the base class character body 3D, it has built-in functions to help the scene to move around. That's why we use that one. It needs a collision shape, so click on the plus icon here and add collision shape 3D. Let's add a new shape. Let's have it as a capsule shape. And the height will be 1.8 and the radius will be 0.25. That looks good. Then click on the root node again. Let's add another node. That will be just node 3D, and I will call it head. And under the head, let's create a new node. That will be camera 3D. Like that. And then click on the head and move it up. Like that. I think that looks good, yeah. Click on the root node. And let's create a script for this player. So make sure you have player selected, and then up here, the script icon, press that. And we're gonna create a script called player.gd. Okay, create. First, let's declare some variables for the player. Normal speed, sprint speed, jump velocity, gravity, and lastly, mouse sensitivity. So what is this colon here? Well, it means that it sets the type to whatever it's declared as the default value. So this default value is a type of float, so it means that it sets float as the type for the normal speed and it cannot be changed later to anything else, such as a string, which is text. So if I'll just duplicate this real quick, you don't have to do this. And here I'll type float. These two lines are exactly the same right now. Alright, I'll delete that. And if we want to change these values, it's gonna be now a little bit slow to change them from the script. So we can do a little trick. Before the var keyword here, let's add @export. And you can see now if you click on the player, here in the inspector tab, we can change the normal speed. Like that. Let's do the same for all the variables. Like that, and save. And you can see all of them here. We can change them from the inspector now. That's neat. We also need to cache the head in our script because we want to rotate it when we move the mouse up and down. So how do we access it? Well, you can actually just drag it here and hold Ctrl and drop. And now we have a reference to the head node from our player script. And this onReady keyword here, it means that the variable sets its value to this value whenever the whole scene tree is ready and loaded. So if we removed the onReady keyword here, when the script loads, it tries to access the head node, but the head node isn't loaded yet, so it can't access it. So let's add the onReady keyword here. Okay, let's create a function. It will be func physics process and press enter so we can use autocompletion. Make sure that the function name is written exactly like here and it has a delta float variable as a parameter. Because underscore physics process is a built-in function, it runs once per frame and that is by default 60 times per second. So we want to do our moving logic in the physics process function for the player and everything else. So from the physics process, let's call a function called move and let's create that function now. Func move. It will be a void function, it's not gonna return any value. And by the way, in the last episode when we enabled add type hints from the editor settings, now when we use autocompletion, it adds this word here and this word here. So we get a little bit more out of it when we use autocompletion and makes the script a little bit more clearer. I recommend using it. Okay, let's create basic movement first. We need to get our input direction from our key presses. So let's create a variable var input dir, short for direction, colon equals input dot get vector, and here we have to set parameters move left, move right, move forward, and move backward. So move left. And these are, by the way, the input actions we just declared, and it will check those inputs, then move forward, and then backward. So if you hold Ctrl and click here, you can see what that function does. This is a built-in function which gets an input vector by specifying 4 actions for the positive and negative x and y axes. And if we go up, we can see that it's part of the class input, a singleton for handling inputs. So that handles key presses, mouse buttons, movement, gamepads, and input actions. So you need to access the input class whenever you want to read any inputs from the user. Alright. Then we need to take in account our current rotation of the player. So let's create another variable, var direction, colon equals, and in parentheses, transform.basis times, let's create a new vector 3. And here inside the vector 3, we are gonna give x, y, and z values. And those will be input dir.x, then 0 for the y, so we don't go up or down by default, and then input dir.y. Sorry, we don't need these parentheses around the whole thing. Alright. So, these transform and basis are also built-in variables of Node 3D, so if you hold Ctrl and click, you can see what they mean. So, transform local space transform 3D of this node with respect to the parent node. And if you click on transform 3D, you can see a 3x4 matrix. It can represent transformations such as translation, rotation, and scaling. Translation means the position. So that's what the transform holds within. And we get the basis, which includes our rotation and scale, and we multiply it by a new vector 3, having our input directions inside it. I'm not quite sure how this works behind the scenes, but it will get us everything we need. A direction we want to move in, taking in account our current rotation. Then, velocity dot z equals direction dot z times our normal speed. Let's do the same for x. So let's just duplicate this. Velocity dot x equals direction dot x times normal speed. And this velocity, it's a built-in variable of character body 3D and also 2D. It's a vector 3, and it holds the information where we want to move. But just setting the variable doesn't move us yet. We need to call a function called move and slide. That's also a built-in function of character bodies, and it moves the body according to the velocity variable. Let's try this real quick. So go to main game, 3D view, and let's add our player here. I'm just gonna drag it from the file system, like that. And I'll move it up a bit, like so. And let's try running the game. Select current. Yep, and as you can see, when we press on the keys, our character moves in the world. But we can't rotate ourselves yet, and we cannot look up or down. Let's do that next. Back to the player and script. Let's create a new function. Or actually, let's override a built-in function. It's func underscore input. Alright. And this function gets called every time the script detects some input, or the node I mean. So we want to check if this event variable is mouse movement, because this event holds the information to whatever input was handled. So we can check it with if event is input event mouse motion, like that. So if it's mouse motion, then let's call a function called look around, and let's pass a parameter there that will be event dot relative. Like that. And what is this relative? Well, if you hold Control and click, you can see we are in the documentation of input event mouse motion, and relative is the mouse position relative to the previous position. And that's exactly what we need for the rotation. Alright, let's go back to player script. And by the way, you can close these tabs here by pressing the middle mouse button. Let's create that look around function now. Func look around. The parameter will be relative, and the type is vector2. Relative, like that. And that's a void function. So let's add some logic here. First of all, let's rotate the whole player on the y-axis relative to the sideways movement of the mouse. And there's a nice built-in function for that. Rotate Y. And here we need to put the angle, and that will be minus relative dot x times our mouse sensitivity. And then to look up and down, we need to rotate the head on the x-axis. So head dot rotate x minus relative dot y times mouse sensitivity, sorry. Let's try that real quick again. So click here or press F5. And yeah, we can look around. But we have two minor problems now. We can actually see the mouse, which we don't want to see when we're in a first-person perspective. And then if I look too much down, we can actually rotate ourselves too much and break our neck. So let's fix that. First, let's hide the mouse. So above physics process, let's add a new built-in function. Func ready underscore ready. And this function gets called whenever the node is ready and all the child nodes also have loaded. And then here in the ready function, input dot set mouse mode. And here you can see we have already some autocompletion choices here. And that will be input.mousemode captured, and press enter, like that. But then how do we exit from the game? Well, let's do it in a way that when we press ESC, we can see our mouse again. So I'll just copy this line. And after the look around function, I'm gonna overwrite another built-in function. It's func unhandled key input. And this function gets called every time there is a key input from the keyboard and it hasn't been handled by anything. So we can check it by if event.is action pressed UI cancel, and instead of mouse mode captured, we will use mouse mode visible. And what is this UI cancel? We never put it in the input actions. Well, if you open up your input map and you tick this show built-in actions, we can see here UI cancel and it has escape as a key input. So whenever we press ESC, we can see our mouse again. Then the rotation problem with looking around. We can do it in one line. Let's just clamp the rotation on the head on x-axis. So head dot rotation degrees dot x equals clamp f, which is for clamping floats. It's a built-in function. And then the value we want to clamp, so that's gonna be again head.rotation_degrees.x, so we can copy this. And then the minimum and the maximum values for that. And that will be from -90 to 90, right? When you look down, it's -90, and when you look straight up, it's gonna be 90. Let's test now. And yeah, we don't see our mouse. And the rotation is clamped on the head. And when we press ESC, we can see our mouse again and we can close the game. Now let's add sprinting and jumping and gravity to our player. First, let's do sprinting. So, in the beginning of the move function, let's check if we are on the floor. And there's a built-in function to check that. That's if is on floor, So if we are on the ground with our player, let's have a variable here is sprinting equals input dot is action pressed sprint. And we haven't set this is printing variable anywhere, so let's just set it here, right above it. So var is printing, and that's gonna be a boolean value, either way true or false. So let's just set the type to bool. And then after is on floor, we put else. So if we are not on the floor, if we are on the air, is sprinting equals false. So if we are on the ground, if we are pressing the sprint key, and we set that value to the is printing boolean. So it's gonna be either way false or true. And then if we are on the air, we set is printing to false by default. Then above input dir, let's add another variable here, var speed. That will be a float. So let's check if we are sprinting, and then let's set the speed to the sprinting speed or the normal speed, according to if we are sprinting or not. So if is sprinting, speed equals sprint speed, else speed equals normal speed. And you can see this thing takes now 5 lines of code. We can do it a lot simpler. We can actually do all this in only one line. And it works like this. Var speed colon equals normal speed if not is sprinting, else sprint speed. So speed equals to normal speed, if not is sprinting, else sprint speed. That's pretty self-explanatory. Alright. And then when we multiply our direction.z with normal speed, we want to multiply it by the speed variable instead, and also for the x. Like that. And if we test, we can see that when we press shift, we actually don't go any faster. And that's because we are not on the floor. So we only set sprinting to true if we are on the floor and we press the sprint button. But we don't have any gravity right now, so we can't be on the floor. So let's add gravity. So here, if we are in the air, velocity dot y minus equals gravity. Like that. So if we are in the air, our velocity dot y will be accelerating downwards according to our gravity every frame. So let's try now. And we can see we just fell through the world. And why is that? Our player has a collision shape, but the island doesn't have any collision on it. It's just a 3D mesh, just a 3D model. We can very easily add a collision to it by clicking on the terrain mesh. So click on terrain mesh, and then here in the mesh button, create tri-mesh static body. And now it created a static body node, and under that a collision shape with the shape of the terrain itself. So now if we try, yep, now we are on the floor, and if we press shift, we move faster. We are sprinting. Very nice. Next up, let's do the jump. And we just need 2 lines for it. First of all, we want to be able to jump only if we are on the floor. So after is sprinting, if input dot is action just pressed jump velocity dot y equals jump velocity. So what is this difference between is action pressed and is action just pressed? If we hold down a key, we want to use this is action pressed, and it's gonna return true for every frame that we're holding down the button. But this is action just pressed, it just checks when we start pressing the button, and after that it ignores if we are holding it. So if you hold down the jump button, it's only gonna detect true for the first frame it was held down. And let's test that. When we press space, yep, we can jump. So all the player movement works now very nicely. And we can move through trees because we don't have any collision for them, but we're gonna do that later, you don't have to do it now. That's it for this episode. See you on the next one. Alright, welcome back. Let's add coal mining in our game. So, like tree, it will be another hittable object. It will be a coal boulder, and we can only hit it with a pickaxe. And when it gets destroyed, it will spawn coal for us to pick up. So firstly, we can duplicate our hittable tree. So objects, hittable objects, right click on hittable tree and let's just duplicate it. I'll call it hittable coal boulder. Like that. Open it up. And here we can delete the tree mesh and the residue static body. I'm not gonna use that for our coal boulder, but if you want and you have a mesh, you can. Then I'll just delete the collision shape for the hitbox and the static body. Like that. And I'll also delete the markers. And I'll rename it hittable coal boulder. Okay, let's add the mesh now. So here, coal boulder. It looks like this. And let's create the collision shape for the static body. So when you have the coal boulder mesh selected, up here click on mesh and create tri-mesh collision sibling. And drag it under the static body, like that. And then for the hitbox, let's add a collision shape. Collision shape 3D. And the shape will be sphere, because it fits pretty nicely here. I'll reduce the size a little bit. And put it like that. Yep, that's very good. And now I'll set the item spawn points. So I'll add a marker 3D. I'll put it up like that. I'll click here to have a better view. And I will drop 4 coals from here. So here, 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 and lastly here. And I want to rotate them a little bit, each of them. So just random rotations, like that. And here. And also here. Yep, that looks good. Or I think it will look good. Then if we check our hittable coal boulder, the root, we need attributes for the hittable object, and here we have 3 attributes. You can click this button here, show in file system, and we find it here, and we can just duplicate it. Let's call it coal boulder attributes. And open it up. Drop item key will be coal. Max health, I'll put it to 80. And change the weapon filter. Instead of axe, let's put pickaxe. And that's it. And then click on the hittable call boulder again, and let's drag the call boulder attributes in the attributes slot here. Alright. That's it for the call boulder. Then we need a pickaxe. So go under items, equipables, and we can duplicate our axe. So Ctrl D on the equipable axe. I'll call it equipable pickaxe. And open it. Rename the root to something more appropriate. Equipable pickaxe. Let's add the pickaxe mesh here. So under mesh holder, let's add the pickaxe mesh. And let's update our animation player. So click there. Let's add some more space here. So double click the position text here. And instead of axe, let's add pickaxe. You can very nicely switch the target mesh or the target node by renaming it from here. And also again under the axe rotation, let's add pickaxe here. I just copy the name so I can paste it fast. And then in the use item, let's do the same. Here pickaxe. And here pickaxe again. Like that. And now when we play it, our pickaxe moves instead of the axe. And now we can delete the axe mesh. And that's it, we can close it now. Next up, we can do the pickupable call. So under items and interactables, I want the call to be rigid, like the log. So let's duplicate our rigid pickupable log. Ctrl D. I'll call it rigid pickupable call. Duplicate. Open it up and rename the root into call. Let's delete the log and the collision shape for it. And let's add the call mesh. So mesh is call. And mesh create single convex collision sibling. That will be the collision shape for the rigid body. And then the collision shape of the pickupable area. I'll put it to a sphere. And it will be a small sphere like this, and it fits it perfectly. And on the pickupable area, the item key will be call, and the prompt pickup call, right? Also for the rigid pickupable call, the root, we want to change the collision layers. So our layer will be now small rigid pickupable and not the big one. And our mask is good, but we also want to react with small rigid pickupables. Like that. Okay, let's add some paths in our item config. So open up your item config script. And first let's add the call and pickaxe here. So I'll just add the pickaxe under the axe. So keys.pickaxe. And the item resource. Under item resources, I actually realized we haven't done it yet. So duplicate the axe item resource. Rename it pickaxe item resource. Duplicate. I just drag it there already. Like that. And then double click on the pickaxe item resource. I will use the same values for the weapon, but the item key will be now pickaxe, display name, pickaxe also, and the icon, it will be pickaxe.png. And I'll change the description. And yep, is equipable, leave it on. And let's also do the coal item resource, so let's just duplicate stone. Rename it coal item resource. Open it. Item key will be coal, display name coal. And the texture for the icon. And the description, a black lump of coal. And let's add it here in the item resource paths also. Keys.coal. And here coal item resource, drag it here. Then let's create a crafting blueprint for the pickaxe. So I just collapsed these to have some more space. So resources, crafting blueprint, resources. I'll duplicate the axe blueprint, rename it pickaxe blueprint. Open it. Item key will be pickaxe. And the costs will be the same for the pickaxe as it was for the normal axe, so I don't have to change that. And I'll add the path here under crafting blueprint resource paths. Keys.pickaxe. I'll drag the pickaxe blueprint like that. And then also the equipable item paths. Let's add the equipable pickaxe here. So keys.pickaxe. And here items equipables, equipable pickaxe, like this. And then let's add the coal here in the pickupable item paths, because we want to spawn it. So coal, colon, and here rigid pickupable coal. And that's it. Now let's go to the island and actually add couple coal boulders here. So let's add coal boulder. Here object, hittable coal boulder. I'll drag it and duplicate it. Let's also already add pickaxe in our inventory so we don't have to craft it. So in your inventory manager, ready function, here I will duplicate this line. And inventory index 1 will be keys pickaxe. Alright, let's try it. Yep, here's our pickaxe. We can drag it in our hotbar and we can equip it. And we can hit with it. And first let's try with the tree. Yep, nothing happens. The tree doesn't go down because it has the filter for only axe. And then the coal boulder, we should destroy it with 4 hits. So 1, 2, 3, 4, and yep, there's the coal. And we can pick it up. And we see the coal in our inventory. Let's also try to hit the other coal boulder with our normal axe. 1, 2, 3, 4, 5. Yep, nothing happens because it has the filter for it to be only hittable with a pickaxe. Everything works perfectly. That's it for this episode. I will give you a homework. Make a flintstone boulder the same way we did a coal boulder. Okay, create that one. I'll see you on the next episode. Okay, let's create the campfire. First, let's duplicate tent from our constructible object. Let's duplicate here. Constructible campfire. Let's open it. Rename. Delete the tent mesh and the collision shape. And let's add campfire mesh here. And mesh, create tri-mesh collision sibling. Let's save that. Let's also duplicate the tent equipable. Campfire. Campfire mesh. Click on tent, transform, copy value, then on campfire, go down on transform, position, right click and paste value. And then the scale was 0.1. Actually, we can make it a bit bigger. Maybe 0.2. And we can delete tent now. And no, do not delete related animation tracks. Now under animation player, let's rename these again to campfire. Here, just double click, replace tent with campfire. Then for the animation, and the last one, oh, I made a mistake here. Like this. Let's test the animation. Yeah. We don't have to do anything else. Now let's add a campfire to our inventory and test it. Inventory manager.gd. The fourth place, which is number 3. And we also need to add it in item config. Under item resources, and let's drag the item resource from here. And let's also add it here, equipable item scenes. Items, equipable campfire, and drag it there. And let's also add it under constructible scenes. Okay, let's test. Okay, nice. That works just like we wanted. Next, let's add some fire particles and light in our campfire. Constructible campfire. So just click on the root and add node, particles, GPU particles 3D, create. Under process material, new particle process material, and under draw passes, pass 1, new quad mesh. We have a simple particles that looks extremely bad, so let's make it look good. Open up the quad mesh. Let's make the size 0.2 and 0.2. Material, new standard material 3D. Open that up. Under transparency, let's make alpha. Shading, unshaded. And under albedo, let's drag a texture there. Under textures, circle 32. Now there are circles. And open up billboard. Mode is particle billboard. Now the particles are always facing the camera. And if you go a little bit up, under vertex color, let's enable the use as albedo. This enables so we can alter the color of the particle in the process material view, not in the normal draw pass material view. You can close that up and then open up the particle process material. Our lifetime randomness can be 0.5, so they're not all the same amount alive. And under spawn, position, emission shape, let's make it a sphere. And the sphere radius should be something like 0.25. Now it's creating particles inside a magical invisible sphere, and the radius of the sphere is 0.25. We can close this up. And let's fix the gravity real quick. Under accelerations, gravity, let's make it 1. Okay, that's nice. And let's go back to spawn, velocity, direction, let's put it up, so y 1 x 0. Let's put the spread to 10. And let's add some initial velocity. The minimum velocity is 0.7 and the max is 1. We can make it a little bit faster actually. Max 2 and minimum 1.5. Let's go up a bit under time. Let's make lifetime half a second of each particle. We can close that up now. And amount, let's put 24. So there's more particles. We can close spawn, open up display, scale, and let's add a scale curve here, a new curve texture. Open that up. Open up the curve. Let's start from approximately 0.25. Let's add another by left-clicking. Let's put it up here. And then let's move this down. So they're gonna get smaller. They start up small, then they grow big, and then they go small again towards the end of their life. We can put this a little bit curved like this. But there's no change here. Well, that's because under Draw Passes, Pass 1, open up the material. Under Billboard, enable Keep Scale. So this setting enables that we can change the scale in the process material. Maybe we can make it a little bit smaller, like 0.1. Yeah, I think that looks better. You can choose whatever looks the best to you. Let's close this up. Let's add some color. Open up color curves. And let's add a color ramp. Gradient texture 1D. Open that up. If you click on the smaller rectangle here, we can edit the color. Click here to change the color. For the initial color, let's use D39E00. Let's make it a little bit transparent, like 170. Then let's another color by left-clicking here. Let's open it up. And the color should be D54B00. A nice red color. We can move it back a little bit. For the last color, let's paste the same value, except let's make it a bit transparent again. 170 is fine. Maybe we can make it a little bit more red. Yeah, I think that looks nice. Okay. We can close the color ramp now. And the last touch, let's add some turbulence. Enable yes. Let's put the noise speed random to 2. And influence minimum like 0.01 and maximum 0.06. It adds a little bit wind looking feature. And we are done with the particles. You can scale this box smaller. And what this box is, it's the particle drawing area. Which means when the camera sees this box, it's gonna start emitting the particles. So it doesn't need to be that big. This is okay. Let's also add a light under here. So under root, add node, OmniLight 3D. Let's move it up a bit, like here. Under light, let's make it a bit orange. Something like this is nice. Yeah, that's a nice color. You can see it there, on the rocks and on the wood. If you want to wiggle with these values, you can. I'm gonna leave it like this. And let's enable shadows. So this light casts shadows also. And one last thing. Visual instance. Let's add it on layer 2 also, so it will have an effect on our equipped items. Let's try it. Yeah, that's nice. You can see the shadows are a little bit weird looking, so you can fix that by moving the Omnilight a little bit. Let's move the Omnilight up a little bit. Yeah, I think that's nicer. Let's try. Yeah, that's a lot better. Okay. See you in the next episode.